Alright, number 1. Notice we've got this cube out front of the first set of parentheses, so we need to distribute that through into each of those factors. So 2 cubed is going to become an 8. C already had an exponent, so you multiply the exponents, so 6. And D is now to the third power. Now we can multiply that to the next set of parentheses. So 8 times 5 is 40. For the C's, you go ahead and add their exponents together, so C to the 13th, and for D, we'd add those together to get D to the 5th. Number 2 is just like it, except we have a square on the second set, so distribute that throughout. The first parenthesis stays the same. And then I get 4x to the 4th, y to the 2nd. Now I can multiply the two together. 3 times 4 is 12. There's an x, and there's x to the 4th. That's a total of x to the 5th. And for y is 4 plus 2 is 6. Number 3, we've got a fraction we're going to simplify. So the 12 over 48 will simplify to 1 over 4. A squared, we can cancel out 2 a's here. Cancel out 2 of these, leaving us with a to the 4th. For b's, I can cancel out 3, all 3 from the denominator, leaving me with a b in the numerator. And for c's, I can cancel out 3 from the denominator, leaving me with c squared up top. So my numerator is now just b c squared. My denominator is 4a to the 4th. Number 4, 2 and 8 will simplify. Then I can cancel out x squared, leaving me with x to the 4th down there. I can cancel out a y, so I have y to the 4th in the numerator. Cancel out z cubed, leaving me with a z in the numerator. So my numerator is left with y to the 4th z, and that's over 4x to the 4th. Number 5, we're going to subtract like terms. So 6x cubed minus 3x cubed is 3. X cubed, oh, sorry, my mistake, that was an x squared, so those were not like terms. So we only have the 6x cubed, so it stays 6x cubed. And then for x squares, there's one here, but we're subtracting it, so it's going to be minus 3x squared. Negative 2x minus 5, that's negative 7x. 1 minus negative 7, that's like 1 plus 7, which is 8. Number 6, I need to distribute. So 2x, add them together to get 2x to the 6th, plus 5, and then x to the 3rd times x is x to the 4th, minus x to the 3rd. And then I now take and distribute the negative 6x to give me negative 12x to the 4th, minus 30x squared, plus 6x. So when I combine like terms, 2x to the 6th, 5 and negative 7 makes negative 12 makes negative 7, x to the 4th, and then minus x to the 3rd, minus 30x squared, plus the 6x. Number 7, gonna have to distribute. Take and distribute that 3x squared throughout. So 33x to the 4th plus 30x to the 5th minus 12x to the 3rd. And now distribute the negative 2x throughout. So get negative 22x to the 3rd minus 20x to the 4th plus 8x squared. So 33 minus 20 is 13, 13x to the 4th. Oh, I forgot I have an x to the 5th. That should have gone first. Maybe I'll just slide it in front. So 30x to the 5th. Okay, now negative 34 x cubes plus 8x squared. Number 8, we can use synthetic division. So put a positive 2 in the box. 1, 4 is x squared, so x, so we have a negative 9, the constant is 10. So drop your first term straight down, 1, multiply it by 2, add to get 6, multiply by 2, add to get 3, multiply by 2, add to get 16. So 16 is the remainder. So I have 1, that was an x cubed, so I lost a degree, so it's x squared. So 1x squared, or just x squared, plus 6x, plus 3, plus, and then the remainder is 16, so that's over x minus 2. Number 9. Use synthetic division, so negative 1 in the box. So 2x cubes, 1x squared. There is no x, so it's a 0, and then a 1. Don't forget that 0. So drop the 2 straight down. Negative 2 is negative 1, positive 1, 1, negative 1, 0. So remainder is 0. So we have 2, and then that was x cubed, so this will be x squared minus x plus 1, no remainder, so I don't need to write the fraction. Number 10, we can do either direct substitution or synthetic substitution. I'm going to do synthetic substitution. So it's just like synthetic division, except I only care about the remainder. X cubed, x squared, x, constant, there were no missing terms, so no zeros. 1, negative 4, negative 7, positive 28, positive 35, negative 140, so negative 134. So negative 134 should be our answer. Did that fast, hopefully I didn't make a mistake. Number 11, state the degree. Look for the largest exponent. The largest exponent is 5, so degree is 5. And state the leading coefficient. So on that term that has the 5, the degree of 5, what's its coefficient? 12. Now for these, we look at the picture. So part A, and behavior. So I'll start with as x approaches infinity. So as x goes to the right, f of x is going up, so it goes to positive infinity. As x approaches negative infinity, f of x, okay, so as we go to the left, it's going down, so it approaches negative infinity. So there's my end behavior. Determine whether it represents an odd degree or even degree. The right side's going up, left side's going down, they don't agree, so that's odd. C, state the number of real zeros. How many times does it touch the x-axis? 1, 2, 3, 4. Now, I know that this what appears to be 0 was a double root because it bounced. So if you wanted to count that as 2 and argue that there's actually 5, you know, I can understand that, but I would want probably to see why you said 5, you know, if you listed that's a double root. Otherwise, it only touches it 4 times. Determine if it has a positive or negative leading coefficient. Look at the right side's going up, so that's positive. Number 13. If we travel to the right, f of x approaches negative infinity. As we travel to the left, f of x approaches, once again, negative infinity. It's going down. Both sides are going down. Odd or even, both sides are pointing in the same direction, so they agree, that's even. State the number of real zeros, only has 2 x-intercepts. The others are imaginary then. Determine if it has positive or negative. Since the right side's going down, we know it's negative. Number 14, estimate the real zeros. Okay, so we gotta pick a decimal here, so about maybe negative 1.2. And then 0. Looks like to be the only other one. So now estimate the x value of each turning point and if it's a relative max or min. So change the direction down here, so that's negative maybe 0.7. It's negative 0.7. That's a bottom, so that's a min. Then the next time it changes direction is over here. Looks like that's at about positive 1, and that's a max, a relative max. changes direction again here at maybe 2.3. That's a bottom, so that's a min. And then it doesn't change its direction any more times. So now for the smallest possible degree, take the number of turning points, there were 3 of them, add 1 to that, so 4. It's at least a 4th degree polynomial. We did know it's even, so that's consistent. Determine the domain range. Domain, as it travels left, right, and keep going forever, so all real numbers. For range, it looks like it's going up to infinity, but it's not going down to negative infinity. The lowest point is about negative 3.4 maybe, so y can be greater than or equal to that. That's my range. Number 15. Real zeros. Looks like we have one at about negative 1.2. That's the only one. Turning points. Turns at right about 0. That's a relative max. And it also changes over here at 2. And that's a relative min. Determine the smallest possible degree. There's still those 2 turning points. Add 1 to that, we get 3. So it's at least 3rd degree. It is odd. We did know that from the picture as well. Determine the domain and range. It travels left, right forever, so that's all real numbers. That's what we keep seeing on our domain. Range. The right side is traveling up to infinity, left side is traveling down to negative infinity, so it's going both directions forever, so that's all real numbers also. Okay, back page. Factor, this is a difference of cubes. Keep in mind that 64 is the cube of 4. So when I use the factoring pattern, x is my a, 4 is my b, so plug them in accordingly. So it's going to be x minus 4, then x squared plus, now multiply x and 4, we get 4x, plus, and then square 4, you get 16. Number 17, 27y cubed, that's the cube of 3y. 8 is the cube of 2. So as I use my factoring pattern, 3y is the a, 2 is the b. So 3y plus 2. Square the 3y, square the 3, we get 9. Square the y, we get y squared. Then it's minus. Then take the 3y times 2, that's 6y. Plus, now take the 2 and square it, we get 4. Number 18, now we're solving. See, it's a 4th degree, and that's squared, so it, you can think of this in quadratic form. Just put an x squared and an x squared. Plus 2 minus 6. Neither of those factor any further, so set each one equal to 0 and solve. X equals plus or minus I squared of 2 x equals plus minus just the square root of 6. Number 19, it's quadratic form again. Looks like we have plus 6 minus 4. X squared minus 4 will factor again to x plus 2, x minus 2. Set each factor equal to 0. Oops. So we get plus minus I squared of 6. Then we get negative 2, and we get positive 2. Number 20, sketch a graph with the degree of 3, zeros at negative 2, 1, and 5. So negative 2, there's a 0, 1, there's a 0, 5, there's a 0. Positive lead coefficient, so I know the right side's going up. It does have a negative sorry, an odd degree, so the left side should be pointing down. Looks good. 21 degree of 3 with one real 0 at x equals 4. So degree of the negative lead coefficient means the right side is going down. And it is a degree of 3, so it's going to have to open up, but we're going to have some sort of change in direction in there, and then change back up. So it could look something like that. Yours might not look exactly like that, but that's a possibility. Number 22, degree of 4, real zeros at negative 3 and 0. Okay, so touch those 2 points, positive lead coefficient, so the right side's going up. It does have, so both sides will open up, but I can't, and it's kind of a W shape. You can choose to bounce off of these, like they're double roots. It doesn't really tell us if they're double roots, so I'm not going to bounce. I'm going to come down. I might change direction, head back through. It could be something like that. There's a lot of options as to what this could look like. That probably should have been a little bit more symmetric than it was, but that's okay. Number 23. So 0 is negative 5, negative 4, negative 1, positive 3, positive 5, positive 7. Has to hit all those points. Negative lead coefficient, so the right side's going down. And it's a degree of 6, so they both point the same direction. Oh, and it has us going down, so we don't have to do any sort of changes at that point. Given a polynomial and one of its factors, so we know this is a factor, so I just left factor it out synthetically. So positive 3, x cubed, x squared, x constant. Oh, hold on, I must have made a mistake because that doesn't have a remainder of 0. Let me check here. Oh, yeah, I don't know why I wrote a 3 there. So everything after I make a mistake is going to be wrong. So 1, 3, 4, so it should be a 12. So 3, positive 3, 9, then I get a remainder of 0. Good, okay. So after we factored out x minus 3, I now have, that was x cubed, so this is x squared, plus 4x plus 3. That factors, so let's factor it down. X plus 3, x plus 1. So we found the remaining factors. Okay, and so now find all of the zeros. So that's assuming this is equal to 0. So set each factor equal to 0, we get positive 3, negative 3, negative 1. Number 25, it gives us a 0. So I'm going to factor it out synthetically. Okay, so I get a remainder of 0, which it should have had. So I factored out x plus 4, leaving me with x squared minus 2x minus 3. So I'll try and factor that. So x plus 1 and x minus 3. So now to find the zeros, so that's what it factors to. Now for the zeros, negative 4, negative 1, and positive 3. Number 26, find all the zeros. So it's 4 terms. Doesn't appear to be factorable by grouping. If that's not the case, perhaps it is, but I'm not seeing one immediately off the top of my head. So I'm going to grab a graphing calculator, and I'm going to graph this. X to the third minus 5x squared plus 5x plus 3. Let's graph that. Okay, so I'm looking for a 0. Looks like none of those were very nice ones. Maybe 3? I could check my table to see if 3 is 1. Yes, 3 is 1. The others were not integers. So I would start with the 3. I would factor that out synthetically. The other ones were not integer answers. Hopefully we can find them, but in a little bit. But positive 3 was 1. So let's start there. Let's synthetically divide that out. 3, 2, 1. Okay, so we have all those terms. Should get a remainder of 0. Good, we got a remainder of 0. So if I have a 0 of 3, that means that there's a factor of x minus 3. And when I pulled that out, I was left with x squared minus 2x minus 1. It looks like that's not factorable. So how would I find the zeros? 3 is one of them, but how would I find those? You can use any of your tools we had last chapter. So if it's not factorable, then we can use quadratic formula. I can complete the square. I may choose to complete the square on this one. I would have added that 1 over. We know we're setting it equal to 0. Add that 1 over. Half of negative 2 is negative 1 squared is 1. So x minus 1 squared equals 2. So I see those answers are real. I already knew that from the graph that they were real. They just weren't nice numbers. Add 1 over. So 1 plus square root of 2 and 1 minus square root of 2, those are 2 of my answers. And then also don't forget the one we factored out. The x minus 3 is a factor, so positive 3 is a real root. So we've got 3 zeros there, 3 roots. Was a degree of 3? I expected 3, so they were all real. Number 27. So 4 terms, doesn't look like it's an easy factor by grouping problem either, so let's just go straight to the calculator. So x to the third minus 3x squared plus 9x minus 7. I'm going to graph that. Just looking for one x-intercept. Looks like there's one there at positive 1. I'll check my table just to verify that it's 1. Yep, 1 has a 0. So I'll synthetically divide that out. X cubed, x squared, x constant. So the calculator is the one that tells me what number to put in my box, so I can't use synthetic division. So good. So I factored out the positive 1, so that's an x minus 1 for a factor, leaving me with x squared minus 2x plus 7. That's not factorable either, so let's set it equal to 0. That's another decent completing the square problem. Subtract the 7. Negative 1 squared is 1. X minus 1 squared equals negative 6. Plus minus x minus 1 equals plus minus I squared of 6. Add the 1 over 1 plus minus I squared of 6. Those were 2 of my answers, and then we already found the 1. So those are my 3 answers. It was cubic, so there were supposed to be 3. We got them. Now the last 2 problems, take the zeros, turn it into a function. I do notice there's an imaginary one, so I know that negative 4i, its conjugate, will also be a root. So turn these into factors. This will be like f of x equals. So negative 2, we're going to have an x plus 2. For the 4i, we're going to have x minus 4i. It's supposed to be an I there. And then an x plus 4i. I'm going to multiply these. I'm going to definitely start with multiplying the ones with imaginaries together first. Make my life a lot easier. So x times x is x squared plus 4ix minus 4ix minus 16i squared. 4ix minus 4ix, they're going to cancel out. We know that I squared, hopefully you remember that I squared is equal to a negative 1. Negative 1. I'll write that again. Negative 1. There we go. Okay. So that's a negative 16 times negative 1. That's like plus 16. So I might want to rewrite that before I FOIL again. In total, that became x squared plus 16. And so now I want to FOIL that. X to the third plus 16x plus 2x squared plus 32. I'm going to reorganize that because that's not in descending order. But I don't have any like terms, so x cubed plus 2x squared plus 16x plus 32. Least degree, yep, would be 3 because we know we had 3 zeros. Integral coefficients, yep. Okay, we're done. Okay, number 29, there's an imaginary, so its conjugate, negative 3i, will be a root also, so there will be 4, so it's going to be a 4th degree polynomial. We've got an x plus 1, an x minus 4, an x minus 3i, and an x plus 3i. I can FOIL the first two together, and I'll FOIL the last two together. X squared minus 4x plus x minus 4. The second one I get x squared plus 3ix minus 3i x minus 9i squared. So x squared minus 3x minus 4 is the first trinomial. Next one, 3ix, negative 3x cancel. Negative 9 times negative 1 is positive 9, so that's plus 9, so that's x squared plus 9. So we're going to distribute. It's x squared. X to the fourth minus 3x to the third minus 4x squared. Then I'll distribute my 9 plus 9x squared minus 27x minus 36. And then let's combine all the like terms. X to the fourth minus 3x cubed plus 5x squared minus 27x minus 36. Alright, that is a degree of 4. We expected 4 of them. All the coefficients are integers, so there we go. Thanks for watching.